So today we're going to be discussing sex-linked traits. And as a review, we're going to talk about the chromosomes that you have from your mom and from your dad. Remember that your mother has 23 pairs of chromosomes, which make a total of 46, and your father has also 46 chromosomes. Notice that your mother has two X chromosomes, while your father has an X and a Y chromosome. So we are going to focus on the X and the Y chromosomes because these are the ones that contain the sex-linked traits. Notice the size difference for the X and the Y. This is because the X chromosome actually contains more genes than the Y chromosome does. I'm sure you've all heard that there's a 50% chance of an offspring being born a female and a 50% chance of it being born a male. Using Punnett squares, we are going to prove that this is right. So as a review for the Punnett squares, we're going to take the X and the Y chromosome from Dad and put them in the boxes below. And then we're going to go ahead and take the X chromosomes from Mom and move them into the boxes to the right. So notice here that 50% of the time we have females and then 50% of the time we have males. So now we're going to talk about what happens when the mother has a recessive trait on one of her X chromosomes. For this mother, she actually has a normal X chromosome that is dominant over the recessive trait, so she is not going to express that trait. But there is a possibility that she might pass it on to her offspring. The females in this case that got that recessive trait on the X chromosome have a normal X chromosome to kind of hide that recessive trait. But unfortunately for the males, they only have the damaged X chromosome, so they're going to have whatever that trait is. There are a couple examples of sex-linked traits, one of them being red-green color blindness, which is when an individual cannot distinguish between the colors red and green very clearly. There's male pattern baldness, and then hemophilia, which is a blood clotting disorder. So I'm going to start with the example of color blindness. There's going to be a normal female who has a capital C on both of her chromosomes. A normal male is going to have a capital C on his X chromosome. Notice that there are no C's on his Y chromosome because the Y chromosome does not carry the color blindness trait. The female carrier is going to have a capital C on one of her chromosomes and a lowercase c on the other chromosome, while a colorblind male is going to have a lowercase c on his X chromosome, and a colorblind female needs to have two lowercase c's on each of her X chromosomes. So now we're going to create Punnett squares using the color blindness trait. We are going to cross a normal male with a female carrier for the trait. We're going to set up our Punnett squares, and the results are a normal female, a female carrier, a normal male, or a colorblind male. I want you to go ahead and write down this information on your worksheet and answer the questions. What's the probability of a male being colorblind? Probability meaning possibility. I want this in percent form. So looking at the males, he can either inherit an X chromosome with a capital C or a lowercase c, but 50% of the time, he has a chance of inheriting the lowercase c. So then what's the probability of a female being colorblind? It's going to be 0% because she needs to have both of her X chromosomes with lowercase c's in order to be colorblind. So what's the probability of a female being a carrier? It's 50% of the time because she has that lowercase c. So now we're going to create Punnett squares using the hemophilia trait. We're going to cross a normal female with a male that has hemophilia. So setting up our Punnett squares and looking at our results, I want you to write down this information in your worksheet and answer the questions. What's the probability of a male having hemophilia? Looking at the X chromosomes that the males inherit, they're always going to have a capital H from their mother. So he is not going to have hemophilia. What's the probability of a female having hemophilia? Looking at the X chromosomes that the female has inherited, she will always have a capital H on one of her X chromosomes, which is dominant, so she will not have hemophilia. So what's the probability of a male being a carrier? Well, since the Y chromosome does not have the trait for hemophilia, he will not be a carrier, no matter what. Males either have it or they don't. So what's the probability that a female will be a carrier? Looking at the X chromosome that she inherits, you notice that 100% of the time, she is actually going to have an X chromosome that has a little h on it that she inherited from her father. So that concludes our discussion on sex-linked traits.